Good morning, dear cadets. So today I am going to teach you another compound of phosphorus, that is pH3. So method of preparation. Method of preparation means first I would like to teach you general method of preparation and afterwards I will teach you the laboratory preparation. So just try to understand. The first method is treating calcium phosphide with water. So just try to understand here. Calcium is 2 positive and phosphide ion P3 negative. This is phosphide ion. Phosphide ion. Okay. So if you crisscross, so you will get Ca3P2. This is calcium phosphide. This calcium phosphide, when react with water, it form calcium hydroxide and phosphine gas. Phosphine gas. Similarly, aluminium phosphide react with water and form aluminium hydroxide and phosphine. Please balance the reaction. So here also Ca3. So 3 2s are 6 and 9. Now here phosphorus is 2 pH3. So 3 2s are 6 and 3 2s are 6. So 12. So here 6H2O. Same way you can balance this one also. 3 6 is there. Now balance same way this one. Calcium phosphide react with the hydrochloric acid and it form calcium chloride and pH3. So just try to understand, these three are general methods of preparation. So what is the generalization of these three methods? Generalization is when metallic phosphide react with water or dilute acids, they form pH3 gas. pH3 gas. Next one is laboratory method of preparation. What is the next one? Laboratory method of preparation. In laboratory method of preparation, what is there? White phosphorus. White phosphorus. Already I taught this reaction. White phosphorus react with sodium hydroxide. White phosphorus react with sodium hydroxide and water, and it form pH3 and sodium hypophosphite. Sodium hypophosphite. This one, sodium hypophosphite and pH3 gas. Now try to understand here. This is an example of disproportionation reaction. Why it is an example of disproportionation reaction? Here the oxidation state of phosphorus is 0, but in pH3 the oxidation state of phosphorus is -3 and oxidation state of this phosphorus is +1 here. So the meaning of this one is same element is undergoing oxidation and reduction. Just see P0 to -3. So there is a decrease in the positive oxidation state, that is increase in the negative oxidation state or decrease in the positive oxidation state, that is reduction. That is reduction. And here it was 0, but now here it is +1. So this is, there is an increase in the positive oxidation state, that is why it is oxidation. It is oxidation. So if there is an increase in the negative oxidation state, that is reduction. If there is an increase in the positive oxidation state, that is oxidation. So here same substance is undergoing oxidation and reduction. Same substance is undergoing oxidation and reduction, that is why it is an example of disproportionation reaction. There is one more characteristics of disproportionation reaction. Same element has to exhibit 3 types of oxidation state. First one is the highest one, second one is the intermediate and the lowest one. So highest one and lowest one should be present in the product side, and intermediate one should be present in the reactant side. So these conditions are met here. Just see, the intermediate is 0, lowest one is -3, intermediate one is the +1. So intermediate one is present in the reactant side, while the lowest one, that is -3, and intermediate one, that is the +1, is present in the product side. That is why it is an example of disproportionation reaction. It is an example of disproportionation reaction. Now one more question is there. PO is not formed. Just see, P2O3 is formed, P2O5 is formed, but just try to understand, That too, these P2O3, they are not stable in monomeric condition. This is stable when it will form the dimer, that is P4O6. This is stable when it will form P4O10. Okay, so just try to understand. Phosphorus oxides generally in the monomeric condition they are not stable. What is the reason? The reason is very simple. Just try to understand. Phosphorus is not capable of making p-pi bonding. That is why the phosphorus oxides, especially in the monomeric condition, they are not stable. But in dimeric condition they are stable. So in dimeric condition their oxidation state will be satisfied, and I will tell their structures also. Let me teach the halides and oxides of phosphorus, that time I will tell you. Here question is PO does not exist. The simple reason is phosphorus is not capable of making p-pi bond with the oxygen due to its bigger size and lower electronegativity. That is why PO does not exist. Anyhow, P2O3, P2O5 exist. That too in monomeric condition they are not stable. They are stable only in dimeric condition. The dimeric form of P2O3 is P4O6 and P2O5 dimeric form is P4O10. So this is all about the laboratory method and general method. There are so many things about the laboratory method. What are those things? Just try to understand. Whatever pH3 is formed in the laboratory method here, that is not pure, that is impure. Why it is impure? In addition to the pH3, during the course of this reaction, small amount of P2H2 is also formed. P2H2 is also formed. Not only this one, some amount of this phosphorus vapor, white phosphorus vapor is also present along with the product, and these are highly inflammable. Okay, so for the preparation of pure pH3 something more is required. So let us continue with the laboratory method only. Now some more important information. pH3 may catch fire in air. To displace air, CO2 is supplied. So try to understand, when we are in the laboratory preparation only. When we prepare the pH3 in the laboratory, immediately pH3 may catch fire because pH3 is a highly inflammable. So to displace air, CO2 is supplied. And what is the function of CO2? CO2 create inert atmosphere. How? Because if CO2 is there, so oxygen will not reach to the pH3 and it will not burn. This reaction is an example of disproportionation reaction. Already I told you. Pure pH3 is non-inflammable, but impure pH3 is highly inflammable. The impurity of pH3 is caused by the mixture of P2H4 and P4. So just see, during the course of preparation of pH3, some amount of P2H4 and P4 vapor, white phosphorus vapor, are present along with the reaction mixture, and they are highly inflammable. It is difficult to prepare pure H3. Pure pH3. So now purification of pH3. How you will purify the pH3? So for the purification of pH3, the refrigerant condenses the impurity of P4 and P2H4, having less freezing point. Pure pH3 is collected. Just see here. Now whatever pH3 you have prepared, so that is impure pH3, because there is a mixing of P2H4 and P4 vapor. Okay, now this impure pH3 you should supply to U type of tube, where you have taken the freezing mixture, or refrigerant. Now this freezing mixture will condense the P2H4 and P4 because their freezing point is less, and pure pH3 will be collected here. Upper side, that may be one pot or apparatus where it will be collected. P2H4 and P4 will be condensed here only. So in this way your pH3 is free from impurity. There is one more method for the purification of pH3. Just try to understand. This pH3, see the method. This pH3 should be treated with pH3. Here lone pair of electron is there. This should be treated with Hi. This should be treated with Hi. Then what would be there? Now this would be pH4 positive and here I negative. pH4 positive is phosphonium ion. What is this one? Phosphonium ion. What is this one? Phosphonium ion. So this is phosphonium iodide. Phosphonium iodide. And now try to understand. pH3 only can react with Hi. Okay. Impurity, that is P2H4 and P4 plus Hi, no reaction. So what is there? Try to understand. Now pH3 should be made to react with Hi. Okay. So you will get the phosphonium iodide. This phosphonium iodide pH4. Now here what is there? Positive, I negative, dissociated into pH3 plus Hi separately. So now this pH3 is now pure. Okay, because impurity will be there only. So this is also one of the method of purification of pH3. Now impurity will be left behind because they are not reacting with Hi. Okay. Now this further will be dissociated into pH3 and Hi. So now you have got the pure pH3. Okay. Now what is there? Impurity will be left there only. Now pure pH3 you have got. Now there is one implication of this reaction. What is this one? This reaction proves, here I am writing, this reaction proves that pH3 is Lewis base. This reaction proves that pH3 is Lewis base. Okay. Why it is Lewis base? Due to presence of lone pair of electron, and due to the presence of lone pair electron, this is reacting with Hi. Now P2H4 and P4, they don't have lone pair of electron. That is why they do not react with Hi. So this is clear cut indication of Lewis base nature of pH3 due to the presence of due to the presence of lone pair of electron. Dear cadets, now this reaction you can alter also. Just try to understand. This should be treated with, just see, pH4 positive, I negative should be treated with KOH. Then what is there? You will get Ki plus H2O plus pH3. This pH3 is pure. Okay. Now why we have used this one KOH? Just try to understand. KOH is very good absorber. And now try to understand here. pH3 is here Lewis base. Okay. But when it donated its pair of electron to the H, so now its basic character is destroyed because positive and negative is there. So now KOH can react with this compound. Okay. Earlier alone pH3 will not react with KOH. Okay. Because this is also Lewis base and this is also KOH is also base. So now this compound only will react. Now you may raise question, sir, you could have taken NaOH also. So try to understand, NaOH is highly corrosive. Okay. you know the basic character. NaOH is highly corrosive. KOH is also corrosive, but it is soft corrosive. Okay, and try to understand, it is less caustic. Less caustic means it does not produce burning sensation. KOH, NaOH produces highly burning sensation. Because of these two reasons, we are using KOH. In this way, you have got the pure pH3. So dear cadet, now structure of pH3. The structure of pH3 is like that. Trigonal pyramidal. One lone pair of electron is there and the bond angle is like that, 93.6, and the pH bond length is 142 picometer. Okay, now properties, physical properties, very simple physical property. Lewis base, you know, poisonous and denser than air, having a smell like rotten fish and colorless, slightly soluble in water. Solution of pH3 decompose into red phosphorus and hydrogen in presence of sunlight. I wrote the reaction also. Just see, pH3 under sunlight, what is there? Red phosphorus and H2, it is decomposing. Okay, now just try to understand. Now the most important thing, pH3 react with some metallic salt. Okay, what are the metallic salt here? Copper sulfate, HgCl2, mercurous chloride, and silver nitrate, AgNO3. I wrote here. Just see, 1, 2, 3. Okay, and the fourth one is here. Okay, try to understand, space problem is there. So remember, just see, when pH3 react with copper sulfate, I am explaining here. pH3, okay, what is the oxidation state of phosphorus? -3 plus copper sulfate. In this way you can remember the reaction for a long period of time. Here what is there? Copper is +2, sulfate is -2, and hydrogen is here +1. Okay, no problem. So try to understand, the hydrogen is +1 and this side sulfate is -2. So the +1 will react with the -1, and here what would be there? H2SO4. Now what is left here? Copper and phosphorus. Now try to understand, copper is 2 positive, phosphide ion is 3 negative. So crisscross this one, Cu3P2. Okay, Cu3P2. This is cupric phosphide. What is this one? Cupric phosphide. What is this one? Its PPT is black color PPT. In the same way, silver chloride also react. Same way, just see. Mercurous chloride also react. Just see. HgCl2 plus pH3. So phosphorus is -3, hydrogen is +1, mercury is +2, chlorine is -1. So just see, one of the product will be 3SCl. Now question arises here, how mercury Hg2 positive and phosphide 3 negative ion will react. So that they will react in this way, Hg3P2 here. What is this one? This is mercurous phosphide. I wrote here, mercurous phosphide. This is also mercuric phosphide. This is mercuric phosphide. What is this one? Mercuric, because now oxidation state is +3. Mercuric phosphide, and its PPT is also black only. Precipitate is black only. Now reaction is, you can balance the reaction. Now write here 2pH3 in the same way, 3SCl and 3 2s are 6. So here what would be there? 6SCl. Balancing please you do. Okay, so oxidation state here 3 2s are 6 plus 3. Yes, 3 2s are 6. So here 3 2s are, actually this is mercurous only. Mercurous phosphide. Okay, same way silver will also react. silver nitrate. So silver nitrate single positive, Ag is single positive. What here will form? Here form silver phosphide, Ag3P. Just you remember these three reactions are very important. Ag3P. This is silver phosphide. This is also black PPT. And as far as the reaction of PH3 with HBr is concerned, just like HI reaction will be there and phosphonium bromide will form. Okay. So in this way now the reaction of metallic salt with the PH3 is over. That is, remember this is mercuric phosphide only. Mercuric phosphide, not mercurous. Mercury is exhibiting two oxidation states, single positive and Hg2 positive. So Hg2 positive is mercuric, Hg single positive is mercurous. So here this is mercuric only. Okay, mercuric phosphide. Now uses of PH3. So there are two uses of PH3. First one is in Holmes signal. In Holmes signal. Just see. What is the use of Holmes signal? Just see. Warship, you might have heard about nowadays. This word is very famous. Warship. If they are traveling in the sea, they require smooth path. Suppose on their way, if any rocks or island is found, then what is there? There will be the wreckage of ship. So what is there? Home signal helps in the finding out of path. Finding out of path and danger in the path of warship. How? Just try to understand. How phosphine is related with this one? Try to understand. Calcium phosphide and calcium carbide is taken. Okay. And now what is there? In one apparatus. And that apparatus should be kept too near the danger area or the rocky area. Okay. And now in that vessel small hole is made. If small hole is made, it will react with water. So when it will react with water, then what would be there? It will form calcium hydroxide. And what is there? PH3 plus C2H2. Now try to understand. Now hole is made on the vessel, and through that hole these two compounds will dip in the water. They will percolate in the water. So calcium phosphide will react with the seawater and it will form phosphine. This phosphine will easily catch the fire. Now once it catches fire, okay, so now try to understand that fire should sustain for long period of time. Now this PH3 will transfer its heats to acetylene. Transfer this one to acetylene. Now acetylene will also burn. And now that flame will sustain for long period of time. Okay, it will sustain for long period of time. Now try to understand. Suppose warship is going. So now if flame is burning, then what would be there? Now that ship will come to know that this particular area either rock is there or some other obstacles are there, and now they will change their trajectory, they will change their path. So now who has helped? Phosphine is only helping in the preparation of whole signal. There is one more preparation, that is the smoke screen. What is that one used? Smoke screen. So second application is in preparation of smoke screen. Now try to understand. In warfare it is made. In warfare. Now try to understand. In preparation of smoke screen, we are taking calcium phosphide only. This calcium phosphide react with water and form calcium hydroxide plus PH3. What is there? Calcium hydroxide and PH3. This PH3 will react with atmospheric oxygen. And what it will form? It will form P2O3 or phosphorus plus H2O. Now this phosphorus will react with atmospheric oxygen and it will form P2O3 or P2O5. P2O3 or P2O5 plus evolution of. Now just try to understand. This white phosphorus or phosphorus, it is highly inflammable. So it will burn in presence of oxygen. So P2O3 or P2O5. Then what would be there? Here smoke will be generated. Smoke generation. What would be there? Smoke generation. If smoke is generated, that is only smoke screen. Full everywhere, what would be there? Smoke and smoke. So from where you have started? You have started with the calcium phosphide, and this is PH3. What is this one? PH3. And this PH3 only subjected for oxidation. Okay. So now please balance the reaction. Somewhere I may not balance the reaction, but you can balance the reaction. Now 2 here write 4. So yeah, 12. Here write 6. Now 6. Yes. 3 to the 6. Now everything is balanced. Please balance the reaction. Somewhere I may not have balanced the reaction. So these are the two special uses of PH3. There are some questions, and that question I will not explain. I hope that you can do this one. Just you note down the question. Already I told you, hint I will give you. The bond angle in PH4 positive, phosphonium ion. Bond angle is large. Larger than PH3. Why? Okay. Are you getting my point or not? Question number. Phosphonium ion bond angle is larger than PH3. Why? Okay. Phosphonium ion bond angle is larger than PH3. Why? Okay. Just very simple thing is there. In PH3, what is there? Lone pair of electron. PH4 positive. Lone pair of electron won't be there. But in PH3, lone pair of electron would be there. So just see, lone pair bond pair repulsion would be there. And because of lone pair bond pair repulsion, there is a shrinking of bond. While in case of PH4, what is there? Bond angle is, lone pair electron is not there. That is why shrinking. Lone pair bond pair repulsion won't be there. And bond will not be shrink. Okay, so PH3 structure. This is the answer, very easily you can write. Please see this one. Only the thing is, here lone pair won't be there, there lone pair will be there. Okay, in this way the duration of today's video is over. Thank you.